You're welcome. So in this short video, what I'm going to show you is just what is actually expected. I want to just make sure there's no ambiguity about anything. So I'm going to be walking through an example project, start to finish, just really quickly here. So this is just real quickly. I'll show you. I got a data set that has reading, writing, math, science, and social science scores for different students. The ID number, ID is the student uniquely. It has the gender of the student, the race of the student. I'm not exactly sure what this says is. There's a school type, public, private, and there's also programs. So real quickly, you see I've got continuous variables, I've got categoricals all in here. So I've got definitely more than two continuous variables, more than actually I've got two categoricals at least. So my data set's meeting the very minimum standards right there, actually exceeding those a little bit. So first off, what we need to do is to histogram our our different types of continuous. So remember, the story that you're going to be telling is going to be one of, uh, basically, uh, the story is going to be seated in your continuous variables. So my continuous variables: math, reading, science, social science, writing. Okay, so what I'd like to maybe just propose is that, I'm kind of curious, is there a correlation between, say, like math and writing skills? And is that different maybe by gender or by some of these categories? So maybe we can take a look at that. So first off, what I wanted to do is look at the adequacy of the data sets. So that to look at adequacy, I need to look at my continuous variables and make sure there's substantial variation. So the first thing you're going to do is scatter plot. So I'll take, let's say just math and writing. Okay, so I'll do math. Let's do a histogram of this. Okay, so then you're going to want a histogram with the smallest bin size. So these bin size are, you see the scale on the bottom. It's got from 36 to 40. So let's go adjust the bin size, and let's go ahead and edit the bin. And I'm just going to make the bin of a bin size of 1 to see what that looks like. Okay, it looks like there's plenty of variation in this data set. It looks kind of normal. Okay, you don't have to have a perfectly normal distribution. If your distribution is completely skewed, then you're going to want to probably log transform it. Okay, so looks like math is okay. I'm going to go ahead and now just do this scatter of math. I'm going to label this. I'm going to label it up here. Let's scatter math, just so I know our math score. That should be more. You want to keep everything organized because you'll be putting this together, and you have to have some cohesive title so that I know what I'm looking at. So that shows that's one graph you'll be creating. Now I need to create another one for, I did for math. Let's do it again for writing. Histogram it. Go to the bin for writing, bin, and let's go edit. Where is it? Edit, and let's do a bin size of 1. I'm pretty sure I'm going to have good variation here too. It is, I see that there's quite a bit more gaps and things. Looks okay. I wish it was a little bit better than this. There's some missing and there's some, but it's generally probably still acceptable. We're just going to run with it, okay? We could also look, if we're not convinced about this. So maybe scatter right. And let's go scatter right writing score. Okay, that's okay. Now let's just look at a different one. How about math? We know math and science are probably going to be correlated. Let's look at reading just to explore it a little bit. I don't want to do anything too obvious because then it's just not interesting. So where's reading bin? Writing reading bin. Okay, let's go ahead and edit this. Edit, and we'll do again with a scatter with a bin size of 1. Okay, it still has some. It has a good amount of variation. What if I did? It looks like there's still like some gaps, but there is still substantial variation. I'm just going to say that I'm going to go with either one on this because it's just an example. I'm just trying to show you how to do this and kind of technically how to go through it. So we'll do a scatter. This was of reading score. Actually, I could just, it'll put it right up there. The name of the sheet goes right up there. So that's easy. I'll just keep it like that. Okay, so I've scattered these. Now I need to look at sufficient. I'll say these have sufficient variation. They're not just like a handful of values. That's great. Now we need to look at variation or sufficiency in our categorical sets. So I'm going to be, first off, let's go ahead and look up school type. So how about we just click on school type? So private, public, okay. And we need to figure out how many are in here. So remember, the unique identifier is how you're going to fill this out, or how you're going to basically just do the count of the unique identifier. So that didn't quite work. School type ID, no, because actually what I need to do is go ID, and let's go ahead and turn this to a measure, and then we'll throw it in like that. And now it's a sum. That doesn't make any sense at all. So let's just do a count. Count. Okay, so 32 and 68. That's kind of not that adequate. Actually, it's not so adequate. So I'm just going to do, I'll do count school type. Okay, schooling type doesn't really have that good. So the numbers on schooling type, you see, is 32. That's pretty small. Let's look at a different categorical. Let's look at how about gender? Do gender, and again, I'll put the ID, and we don't want the sum, we want the count. So measure, we'll do count. 109 versus 91. You see, this is actually a pretty small set. It looks like there's only 200 observations, but I got 109 and 91 on the gender side. So count gender looks like it's got sufficiency. Let's see if there's another categorical in here. Program, school type. Did I do program? I did school type. What about program? What is that? Academic, general, vocational. I wonder what those counts are going to be. Let's go ahead and find out if we have sufficiency here. Not the sum. Always going to do that to me, isn't it? Let's do the count. Marginally. Okay, so I've got a little better coverage. It's still, these are awfully kind of low numbers. I'm going to have to kind of pause. That's getting really marginally low. I wish these were a lot higher, honestly. With only 200 observations, I got 3 categories. I think this is probably going to be my best bet. So let's go ahead and call this count of, what did I say? Program. Okay, count of program. So let's look at program and gender as the main. So what we're going to do is look at math, and what did we say? We said math, and I got school type, reading. So we'll do math. How about math and reading scores? And we'll look at it by gender and by program type. So first things first is we need to scatter both math and so scatter your continuous variables. In this case, I've got math score, and we're going to go with what did I say? Writing. Okay. And you'll end up with a single dot, of course, because what you need to do is take your unique identifier and put it in the details. Not sum of ID. Actually, you know what? I'm going to change this. Can I duplicate? I'm going to duplicate. I'm going to move the copy of it. I'm going to change the copy actually back to a dimension, and then pull this into the detail. That's going to look better. Okay, so now I've got, obviously clearly it looks like a positive correlation. That doesn't entirely shock me. So again, the correlation and the story here shows, if we do some analytics, we need to put a trend line in here. We see a positive correlation between writing and math scores. Okay, that is probably not that interesting. And that's where our categorical variables are going to come in, because we want to see if there's any difference, say, by gender. So first things first, let's go back to the data. Let's take gender, or race, female in this case, and we'll put it into the color box. Okay, that's a little interesting. You see, this is going to show us. Where's our key? So males in orange, females in blue, and we have that orange is showing us that there's actually a less strong correlation for males than for females. It appears, we can't tell if it's statistically significant, but we do see different slopes here. And so it looks like maybe that's kind of a story to tell, possibly. So there's one sheet. Another would be, let's go ahead and actually, I'm going to go ahead and delete this. Delete. I'm going to copy this sheet, or just duplicate it. Where's duplicate? And instead of gender, let's look at our other category, which I think was program, right? So let's take program, throw it in color. This is kind of interesting. So we're looking at academic, general, or vocational type schools. We see a very strong positive correlation between math and writing scores in academic programs. And actually, though, when we look at vocational and we look at general programs, that correlation is also not quite as strong. So what does this tell us? This tells us that, I mean, these dots, so over here we've got actually, we've got, what do we have here? We have, yeah, so it means that as writing scores go up, math scores are not going up by the same sort of amount that they would in a pure academic setting. That's a little interesting. So yeah, we do see some differences here, and we can try to think about why that is the case. And so part of what you're going to want to do is first present all of this information. So first present data adequacy. Again, you're going to need to create these scatter plots and also these count tables. And then what you want to do to make it as easy is to throw this into a dashboard. So for adequacy, let's just grab our scatter plots of math, and we said writing, right? Let's throw those scatter plots in. And then let's do the count of gender and the count of program and throw those in there, okay? So now I've got one sheet that has all of my information that I want to show, that shows data adequacy. And this can be exported as a PDF file, or you export the whole thing as a PDF file, or as an image file, and then insert it into a Word document and save that as a PDF. There's a lot of ways to go about this. But I've got one of my main dashboards here already. Now I could throw another dashboard. Oops, that's another sheet. I don't want another sheet. I want another dashboard. Delete. Let's go ahead and create another dashboard, and let's look at our main findings here. So we have, and that's got a bad name also, by the way. So I'm going to want to so I'm going to go back to sheet 7. This is why you should title these. So I'll put it down here. This will be correlation of math and English, or was it writing? Writing score by gender. Okay, correlation of math and writing score by gender. Okay, and this second one is correlation of math and writing score by program. Okay, so there we go. And now our dashboard, it put the title right up there. Okay, so I got it by gender, And also, let's go ahead and grab it by program. That might be a little busy. I'd say probably that's too much. So let's go ahead and just take that out of there. And then I think maybe for these scatter plots, in this case, I'm just going to present them. I'll probably export them directly from the worksheets rather than create a dashboard. Okay, so you've got your main analysis here. What can I tell? So you probably want to come up with some stories of why is it the case? Well, first off, it's pretty obvious to think about why do people with higher math scores also have higher English scores or writing scores, and there's probably some sort of a general intelligence kind of mechanism that's driving that. Now, we don't really have enough data to really say anything about why there are gender differences here, or if I haven't even actually statistically tested if there are significant gender differences. But if these different correlations are statistically different, why is that the case? We can't really quite say, but you might just have a quick hypothesis as to why you think it might be the case. What I do see is actually, this is the first time I've actually looked at this data set too, by the way. What I do see is that among programs there's quite more substantial differences, and that's kind of interesting. And I haven't quite understood exactly why this might be the case either. It could be the case. I don't know. I guess in this general type of education program, what does that mean? What does it mean actually if they're not correlated as much? It means as writing is increasing. I mean, we do have some. You see, we do have some. So it means as writing is increased, so the slope is lower. Remember, slope is rise over run. So it's really as so for a given change in writing, how much does my math score change? So if you're really good at writing, but you don't have a great math, so if that doesn't correlate to much of a gain in math score, in other words, if you're just a good writer, but not good at math at all, then it's possible that for whatever reason, you might select yourself or just go into a program that's more general and less pure academic. Um, Likewise, if you're maybe you can write okay, but you're not so great at math, you might go into more likely to just maybe enroll in a vocational school. That's a story that might be here. And that might be what we learned is something is that might be a possibility. So it is actually really tough to figure out exactly what's going on. Again, what we can see is we can see that there are maybe some potential gender differences, but we can't really see why. And that's the limitation with where we're at in the kind of statistics that we've delivered so far. It's hard to really tell why. But what we can learn is that there might be some differences in these categories. And that right there is actually just it's kind of interesting in itself and gives you an idea of some ways to maybe explore further about how you might question, why are there these differences here? And that gives you a seed to continue digging statistically and continue finding out more. And that's pretty much all I expect from you all at this point. I don't expect you to figure out the why. I just expect you to figure out some interesting sort of differences among groups and try to show those statistically so that you can, at least see how to maybe explore further is all we really need from this. So that's it. That's the technical portion. I'll create another little video about how to put this together into an actual submission, so you have that. And this is hopefully going to be sufficient for you to just make sure that you have everything that you need in submitting this project. So, and there's Adrian in the back. Well, say hi, Adrian.
Hi.
Oh, hello. Show your face. Pick it up. Little fuzzball back there. Okay. Say bye-bye, Adrian.
Bye.
Bye.